Ah, hit the button. Means there's video coming. Well, it's happening now, actually. So yes, draft physics video. Just some more stuff I wanted to talk about. Just this whole the basic theory that drives conventional physics, and you can see these sort of whatever they are. These I can't call them cornerstones because there's more than one of them, but these foundational building blocks. And they all talk the same talk in the sense that, you know, the two-slit experiment, the same kind of rhetoric, this was the big evidence, this is the evidence they were waiting for kind of thing, and it proves, you know, a conclusion. Now they don't have to think about, you know, it anymore because they can draw it and write it in stone. And how those were just fundamental mistakes in my opinion, in the process of science, is this idea of the premature conclusion is your worst enemy. Okay, the presumption, and they're all over the place. Physics is just made of taking a little bit of evidence, imagining, and concluding, and it's not very good science. Alright, so you know, there's physics as written doesn't give you any mechanism, doesn't explain attraction or repulsion, doesn't give you a physical thing causing it. It just says these things attract or these things repel. Now, in my explanation, I've given you a simple mechanism that allows for the creation of pressure, and all it requires is creating something we know already exists: positive and negative charge, two opposite polarities that interpret the world in an inverse manner. What makes one thing move doesn't make the other thing move. What's invisible to one is transparent to the other. What's visible is what's opaque to one is transparent, blah blah blah. And that's what you have with the electron and the proton. And this is the strongest manifestation of force, is the relationship between an electron and a proton, in the sense that the electron lets escape the pressure that would be created by the proton. The proton lets escape the pressure that would be created by the electron, and it creates essentially the zero, almost, pressure between them. That is the strongest push. The push is realized to its maximum extent because there's no push between. So there's no ping pong balls bouncing between these two things, therefore they can get closer and closer without consequence, and the external pressure is maintained. And it's that explains attraction and repulsion, and explains attraction as merely the absence of repulsion. No repulsion between you. The repulsion from the external world drives you to something. So it's almost like we see that in psychology. We're driven to the lesser of evils, that kind of thing. Not necessarily something good, something less bad. Not a totally fallacious analogy or comparison. Alright, so I was watching a Susskind video, and it's much older than I thought. He looks older for some reason in this video than he does in, you know, it's like 8 years ago. October 2009. I don't really care for how they describe these lectures, you know, the subject of them. You know, they're not like in any kind of order or any kind of division of physics that to me makes any sense. So anyway, this is called New Revolutions in Particle Physics, Basic Concepts. So he was, you know, he's going on about the discovery. Auction. I forgot about it. We'll see if it's worth it. Oh, it's still at 52 cents, so I guess I'll have to pay attention. So remind me in 5 minutes to jump back. All right. Anyway, so it's a good. I like it just because he's going from the beginning to the end. So he's talking about weighing the electrons and the protons, in a sense, not explaining how they weigh them, but the fact that they did weigh them. And I would argue you can't weigh them. They're not affected by gravity. They have no weight. They only have charge, and so you can measure their charge. And you could measure, say, the density of charge. Perhaps maybe protons carry more density of charge, but they can't carry more, quote-unquote, anything. Well, mass is a manifestation of charge. Gravity is actually, the electric universe people are correct in the sense that, in the very narrow sense, that gravity really is a measurement of charge, because that's what's really holding everything together, is the fact that the protons and the electrons are oppositely polarized. And that's what you're really affecting with gravity. And you're affecting them with magnetic force. So gravity really is magnetism. But whatever, I don't want to confuse things any more than they've already been screwed up. On the subatomic level. So I guess what I would argue is that this is really simple. There's these little matter bits, the electrons, the protons, the neutrons. And you can, whatever, quarks, all the rest of that crap that make up them, but it doesn't really matter. Those are the essential players, and the force bits. The force bits are trapped between the matter bits. And that's it. That's all there is. It's that simple. So it's baseballs or tennis balls, you could say, and ping pong balls. The ping pong balls bounce into the tennis balls, and depending on how many ping pong balls are going in a certain direction and what polarity the ping pong balls are, they come in two colors, black and white. The proton and the electron are black or white, and depending on which one they hit, they have a different reflexive reaction. They gain acceleration, they change direction in a different way. And that's the story. So you can reduce everything just to those two kinds of things. The matter stuff, which doesn't have any intrinsic, it's balanced. That means ideally it's always seeking balance. And the force bits that are interfering with that balance and compelling it to move somewhere else if there's an imbalance. And so electrons are always seeking, quote unquote. Obviously they're not seeking it. They're always being moved by any imbalance. So they always have to find a place where there's balance. The same for the proton. They won't stay where it's imbalanced. They have to find balance. That's all they ever do, is move to balance. Balance in terms of the force. If there's more on one side than there's on the other side of a particular polarization, they will move until it stops being more on one side than the other side. So they'll move until they get near a proton that creates force that negates the other force that's pushing them. They have to get somewhere where something stops them by creating the balance to balance their field that they're in of ping pong balls. So if there was a field, it would be made of ping pong balls. That's my argument. Everything's a bit. There's no field of woo or woo-woo or any other kind of mush. There's tons, like photons, magnetons, gravitons, whatever. It's all tons, little bits that are all forces. All force is made of a something, not a nothing. Not a perturbation, not a wave, not a vibration. It's an actual movement of a bit at the speed of light. All right. Okay, so in this, where he's talking about this stuff, talking about measuring weighing these parts, which I don't think they actually did weigh them in a realistic way. There's no way to weigh an electron. You can't put it on a scale. All you can do, all you'll end up doing is measuring its charge, because that's all it has, and that's all the proton has. So anyway, okay, so one of the things he talked about was some argument about who discovered radiation, and he mentioned Curie, but yeah, she didn't discover it. She was actually in college, and she there was a guy, she was writing her doctorate thesis, I think, and there was a guy in the same lab who had actually done this plate thing where he had put a rocks of bismuth or something next to a photographic plate accidentally in a drawer, and the plates all got exposed by the rocks, and that was the discovery of radiation. So that guy, Bertolini or whoever it was, had invented a way of attempting to see this radiation. So what they do is take a big piece of lead and cut a groove in it, slot a hole, and put the radioactive material in there, and then see what comes out of the hole. And what they found is that, when they put a magnetic field on this, is that, the alpha particles went over here, the beta particles went over here, and the what's the other one? I can't believe I forgot the name of it. Alpha, beta, so obvious, gamma. Yeah, the gammas are the photons. Let's see if I missed this auction. I did. Amazing. You stupid fuck. 52 cents. Alright, what's your fault? I missed our bargain. The sacrifices I make for science. Damn. See, I could have saved like 62 cents. Damn. Half price. Anyway. Better make sure there's nothing else coming up. Let's see, 12 minutes. That shouldn't be up in 12 minutes. Damn. Alright, well I'm gonna have to put a timer on this one so I know. 10-minute timer. And that way I won't fuck up again. Ugh, I'm gonna have to use the keyboard. Sorry, it's a one-man show here. One-man bands don't play great music, and yeah, I don't play great music. I don't do this as clean and efficient as I should. Just so much to do. Just one man doing it. Alright, so gamma. So the photons went, go straight up. The betas get pushed one way. The alphas get pushed the other way. Yeah, right. Alpha is the nucleuses, so they're helium nucleuses, 2 protons, 2 neutrons. So obviously well balanced in the positive. The electrons are obviously negative, so they go the opposite way. And the photons don't do anything, go straight, because they're not affected by electricity or magnetism, because in fact they're a force. They are electricity and magnetism. They are the force that is the carrier of electricity and magnetism. They aren't electromagnetic. They make things electromagnetic. So this is where another one of these key wrong interpretations. So what they think is, oh, it's not charged. Well, it's not charged because it's not material. It's force. Photons are force. They're not matter. So they can't be bent because they can't be charged because they're not matter. They're not a matter bit. Alright. So it's just a misidentification of something as fundamental as what are the matter bits and what are the force bits. The photons are the force bits. The matter bits are electrons, protons, and neutrons. Neutrons are just really a proton and an electron. Alright. So the irony is now he's going to talk about the two-slit experiment, and in a kind of a funny context, because this experiment was done and the light moved straight. There was no indication of a Newton's rings or some other kind of crap, because the opening was obviously probably pretty wide, and so it wasn't even an issue. But in a sense, he doesn't even pay attention to that, because he uses this as a comparison and obviously those were photons, like light. And if this theory was correct, then you would have commented on that being something that existed. But obviously it only exists for very narrow openings, this culmination problem. So anyway, and you should think that, well, if it's very narrow, then there's more likely to be electric fields between the things that are getting pushed together. When you push two material things next to each other, there's an automatic impulse for the surface electrons to repel each other and for them to essentially create a charge. One side will become positive, one side will become negative, because if it doesn't, it wouldn't be obeying the rules of charge. Alright, so let's play some of this.
The electromagnetic field, electric fields and magnetic fields forming waves. When you shake a charge, waves get given off. The wave fields are continuous wave fields, at least according...
Yeah, so again, this is all stated as if this is what happens, that these waves are produced. Now, Einstein demonstrated that that doesn't make too much sense because, yes, everything happens on a quantizable, discrete, tiny point that's impacted. Newton didn't go along with it because Newton saw shadows and said if they were waves, our shadows would be very blurry. Not a little blurry, very blurry. Because waves go right around corners easy. Waves don't have any problem with edges. They go right around them. Light doesn't do that. So it's not waving, it's particling. And surfaces create charge fields in which the atoms that are in the atmosphere or the free electrons that are going to be in the atmosphere, even in empty space, will line up based on that charge field. They'll find a neutral location. And through that process have an orientation. They'll have a disposition, a pointing vector, based on a new position they're in because of the field changes. And it would be reasonable to believe that that field could have essentially create something that we would call a lens. And that's what these field lines that are created between charges create, is something that could be called a lens, because everything has to leave perpendicular to those surfaces. The surfaces of the material, whether it's a conductor or an insulator. Okay, anyway. The electrons and the protons are going to be affected, no matter what the material is, in some way.
Into classical electrodynamics, and they give off waves that propagate through space completely continuously. And Newton, of course, had thought that light was particles, but Newton by that time had been completely relegated to the dustbin, at least as far as theory of light went. There were many experiments.
Yeah, well, again, that's not true, but he does point out Huygens, and so he does bring the controversy way before Young, and basically confirms that the wave theorists, this is their, when people talk about Newton being archaic, no, Huygens is the old archaic view, this stupid wave theory, and it's an old theory. It's not a new modern theory. It's an old theory, and it can be regulated and ridiculed for the same reasons you would ridicule Newton as being some dead 300-year-old guy. Well, so is Huygens. So the controversy existed then, and it hasn't been solved by these, I'd almost say, silly examples, in the sense that Newton had already seen Newton's rings. And in my opinion, Susskind ignores the significance of that. He basically says Newton should have saw that as an interference pattern, even though we know there's single photons and it's a single slit. he should have thought of it as an interference pattern. I don't think he should have done that.
Some of them done by Newton himself that strongly said light is waves.
So he's implying Newton's rings there. He doesn't say it, but that's what he's implying. And he's somehow thinking that because Newton sees an on-off pattern in a single slit, a single aperture, he's supposed to conclude that a single photon goes through a single slit, splits in two, and interferes with itself. I don't think he's supposed to do that.
Not particles. So let's just talk about light a little bit. Electromagnetic radiation. If you take electromagnetic radiation, it comes in waves. So if there's a source of electromagnetic radiation here, an antenna, some form of antenna emitting, could be radio waves, it could be microwaves, it could be infrared, it could be light.
Right. So obviously we don't call a light bulb an antenna. But see, this is where our rhetoric breaks down. This is where, there's problems with the verbiage, because we have these different words to describe emitters, and yet they're all doing the same thing. They're all the same thing. They're emitting photons. They're just emitting them in a different form, with different frequency and carrying frequency. They have their innate frequency like light, and then they have the carrying frequency, and the difference between say a radio antenna and a light bulb is the way the photons are emitted. Well, it's pretty much the same way, it's just the bulk of them, the amount.
It could be ultraviolet. An atom is a perfectly good antenna, incidentally. Doesn't have to be a big macroscopic tower. An atom with a charge going around in a circle is an antenna.
So again, this charge going around in a circle stuff, this is all stuff they've drawn the conclusion that this is how it works. They don't have a video of it. Now they have some evidence that indicates, but again, that evidence you can be easily fooled by things like charge can look like mass. Electric charge can look like a mass. It can look like a weight when it's not.
Antennas.
Okay. Auction time. 1 minute left. Oh, the price jumped up. So this one probably $1.50. I'll wait till next time. Thank you very much. Alright, I should be okay for a little while. Back to the serious work. I hate when I miss auctions. I just hate that. Do it all the time. I'd be a billionaire if it wasn't for all these missed 60-cent opportunities. Damn it.
Waves. And those electromagnetic waves, when they also fall...
So electromagnetic, so let's understand there's absolutely no indication that photons are at all affected by magnetism or electricity. That they in fact precipitate it by interacting with electrons. So if photons don't interact with an electron, they don't do anything called electrical or magnetic. Their only association with electricity is that when ions created by the charge, that is, the electrons hit an atom, it produces another, it knocks the electron loose from the atom, both electrons are now free, so it's a cascading chain reaction of creating ions. So the atoms all end up with an absence of one electron. When that is reversed and the electrons go back into the atom, they release the photon. So that's the only thing a photon has to do with anything electromagnetical. It has nothing to do with it. It is not, there's no such thing as a electric magnetic field that photons at all participate in.
On a photographic plate or other device which is sensitive to light or sensitive to radiation will illuminate that.
Right, and we know it'll illuminate it in dot, 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 dot. No waves will hit it. No, nothing will be spread. It'll just be discrete little tiny dots. Little photons will hit. Little tiny, 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 tiny things will hit.
And turn it white or black, turn it black, I guess. And that's in the character of light. Now, how do we know that these things are waves? How can we tell that they're also not bullets shot out of the source here? So one thing you might do is do something very similar to what was done over here.
So he's using the radiation example, right? So he says something very simple, similar. Well, it's not really similar. Because what was done over there was a big enough opening that it didn't create enough of a movement. And we know that in the single slit, the pattern part is a tiny percentage of the overall light. Most of the light goes straight through. Most of the light goes straight. Only a tiny percentage of the bulk of the light actually gets changed.
Put an obstruction, a little hole, and see whether the light is collimated exactly as if it were bullets being shot out of a gun here. With bullets, you would illuminate a little spot over here. And of course what happens is that you don't illuminate such a small spot.
Right, now, see, it'd be really nice if these people would, like I said, they're physicists, and understand that, okay, well, what's the difference between this and bullets? Well, the difference is that we know that this matter thing has a charge, that all these that, like even the biggest conductor in the world that's carrying electricity, it's carrying the electricity on its surface. It's not carrying it inside the conductor, because the conductor requires it to create no field. The electrons have to find balance. The protons and electrons in the conductor always have to find a balance. So they can't have charge. So the charge has to be thrown onto the surface. And that should tell you something. The fact that there's a difference between when light goes into a surface and then changes what kind of material it goes to. So when there's a transition between water and atmosphere, and there's a huge change in the angle at which the photon leaves, that should tell us something, that there's something different between that barrier between two different atomic structures.
You illuminate something,
And the difference is charge.
which is fuzzier than that.
So this, I don't know why he does that when he knows. Why doesn't he just say you end up with Newton's rings? That's what you end up with.
You illuminated a funny, fuzzy region. But that in itself did not prove that light was waves. Not at all. You could
yeah, of course it didn't. That's why Newton didn't draw that conclusion, which you just ridiculed him for.
say, well, just maybe when these particles go through this opening here, maybe they have little forces exerted on them by the edges of the hole here or whatever.
Or whatever. Yeah, that's sort of, yes. Now, why not pursue that and say, yes, well, isn't that clearly possible? That where does this phenomena take place? Oh, okay, that's right, when you make the hole smaller and smaller. And it spreads more and more as you go smaller and smaller. So there seems to be a correlation between this changing of the charge between these two plates, essentially, that you're pushing together. And we all know that charge dramatically changes as you move plates together and away from each other. I can take 10 volts and make it 100,000 volts just by putting it on two plates this close and then just moving the plates further apart.
Which deflect them, some of them get deflected, and so maybe you get a more smeary picture, a more smeary image than you might have hoped for.
Well, again, like I said, the smeary is not exactly what, we're arguing that there's an interference pattern, quote unquote, created, an on-off pattern, Newton's rings.
So it was not just that the beams got deflected, the light beams got deflected. That in itself was not enough to argue for a particle structure for light.
I mean a wave structure, so I said that wrong.
Or, sorry, a wave structure to light, I'm sorry. But you do something else, which is much more sensitive to the wave character of light. Here's the screen over here again. You open up two little holes.
Right, now, much more sensitive, he says. There's nothing more sensitive about the two-slit experiment. So why didn't you just stay with the single slit and say Newton's rings, and then explain Newton's rings? Because he has Huygens. Now, the only problem with that is then you can't talk about the two-slit experiment because you won't use Huygens the same way. You'll cheat and, reduce what Huygens would create in the two-slit experiment. Huygens creates 4 waves that interfere with each other. And in the two-slit experiment, you need just 2. And in the single slit, you need 2 waves. You need something, so Huygens creates the 2. But obviously it doesn't apply the same way in the double slit. You don't use 2. You just call them single point sources. So it's a complete logical disconnect. No logical continuity between the rules applied in the single slit versus the rules applied in the double slit. Oh shit. Damn, I hate when that happens. See, where was I? Yeah, I hit the wrong button and made a mess. Maybe I have to reload it. Maybe it'll reload in the right place.
The light beams got deflected. That in itself was not enough to argue for a particle structure to light. Or, sorry, a wave structure to light, I'm sorry. But you do something else, which is much more sensitive to the wave character of light. Here's the screen over here again. You open up two little holes next to each other. If light was simply particles, what you would expect to find here is basically 2 smears of the same kind, just superimposed on top of each other, maybe a little extra dense in the center where they overlap, but just 2 smears, one the image of this hole, one the image of that hole, with nothing.
Right, but see the trick is this distance is very far away because this diffraction is so slight. So you only have this when you get very, very close to the 2 slits. So this distance is so tiny that the stuff going straight through would end up being a pea, even at 10 meters, just a pea in size. So conceptually this doesn't pay any attention to what really is happening, as this light does go straight through and that light hits here, and the pattern is just about which ones are getting deflected. So even if you were just going with 2 blurs, that wouldn't be seen as 2 blurs because the stuff that's the strongest part of the blurs are going to not be 2 headlights that are 4 feet apart. They're going to be really, really close to each other. They'll be so close that you're not going to be able to even see that it's 2 headlights.
Unusual. This, of course, is not what happens. What happens is each hole emits waves. You could do the same.
So again, this is he says so. So that's what they say actually happens. All other explanations are now some sort of moot. They're not worthy of consideration. They're worthy of no consideration by any physicist ever I have seen, except for the cranks maybe. But even they don't do it. Nobody except me is talking about some other mechanical cause of the 2-slit phenomenon.
Same trick with water waves. In fact, it's not hard to do the same trick with water waves.
It's really hard to do the same trick with water waves and a single slit. So let me see you do that. Let's just see you create a single slit in a water wave, and let's see you create an interference pattern on the target. Because you won't. You just end up with plain waves, 1 wave front. That's it.
And the water waves interfere. If this is the high point...
So again, if he would have stayed with a single slit, he wouldn't be able to do this. He wouldn't be able to make this argument because he couldn't make a wave argument. He'd have to first explain how Huygens says there's an infinite number of waves in here, and all of these cancel out, and the only ones that survive are these two little end waves, and they go out like this and interfere with each other. And that wouldn't sound quite as reasonable, would it?
Of a wave coming out of here, and this is the low point of a wave. Places where the high points combine from the two holes reinforce each other. Places where a high point from one hole meets a low point from the other hole cancel each other.
Right, so let's understand though that photons don't do that. So we know that there's no such thing as a canceled photon. We know the photon just moves to a different location. So it's just a movement or a migration in its a change in its path. It goes all this way or it goes all that way, but it can't do this way kind of argument.
And so the effect is to see when it hits the screen here, to see bands. Bands of positive reinforcement where the high points add, missing places with no light where the high points meet low points.
Right, and this, again, this gross oversimplification ignores what is almost the most characteristic aspect of the double slit experiment, which is that this banding also has a pattern, which means that it'll have 16 or 17 of these bands, and then it'll go to nothing, and then it'll have 6 or 7, and then it'll have 3 or 4. So it will create bands within the banding is within a banded pattern. So totally ignore an element of the phenomenon because it's just not convenient to the narrow point attempting to be argued. And in my opinion, it's just cheating.
That's an interference pattern. An interference pattern is a real signal of wave-like motion, of wave.
Right, so again, interference pattern, let's understand on, off, on, off, on, off. The simplest pattern that can be called a pattern, and yet they're saying anything that creates that pattern can only create it because of something called interference. They can't create it because they're neutralizing or balancing a field. So if there's two slits being pushed together and there's electrons in those two slits and they bulge out, and they bulge, and then it goes, and then it tightens up more, and then it bulges a little different, loses one of the electrons, pop out. If it keeps balancing itself and creating basically on, off, a feather, a peacock, however you want to look at it, that's not possible in this universe because only things that can create on-off patterns are interference patterns. You must have interference or there's no such thing as on-off.
Behavior. Waves, you can do this, as I said, with water. You just put your finger into...
You can't do it in water. So again, you can't do it in water. One finger in water, you don't get an interference pattern.
Water and wiggle two fingers, and two waves from the two waves will spread out.
So let's see you make Newton's rings in water. Go ahead. Knock yourself out with your finger.
Some places they'll reinforce, some places they'll cancel. And so rather peculiarly, but nothing terribly unusual, places which would have been illuminated by either of the two holes by themselves, there's destructive interference, they get canceled, and places you get constructive interference and they add and you get extra intensity.
Right, and so all that's really saying is that if you change this field configuration, that is you close one of these slits or it doesn't exist, that you would change the charge configuration in this circumstance. So again, charge is what we're really talking about, and when you do this with electrical charge, you'll end up with the 20th, you could have 20,000 volts between these two poles, and then you end up with 10,000 volts independently between these two. So it changes the configuration, the voltage, the force field between the gaps as you narrow the gaps and increase separation between gaps and do all that stuff, you'll change that dynamic, which will change where stuff lands.
That is the kind of thing, this interference property was the kind of thing that really nailed the wave theory of light.
There we go. So again, we've had nail in the coffin, and now we have nailed, which is the simplified version of that, I suppose. And again, the proof is thin, weak, presumptive in every way. There's no hard evidence there. There's lots of ways of saying there's something else happening, and lots of ways of saying it requires almost an extraordinary belief in magic to talk about a single photon creating both of these waves and interfering with itself. And that's what actually happens. Single photons do this landing. He knows that.
So light was a wave. In fact, this did not occur after Newton. It really occurred before Newton. Huygens was a 17th century? Huygens must have been 17th century, but previous to Newton.
Yeah, it wasn't previous to Newton. Newton was getting kind of old, I think, when Huygens met Newton. So they're contemporaries, but Newton was on the way out as Huygens was on the way in.
Who? What? Yeah. Yeah, but Huygens already had the basic ideas of...
So the guy just brought up Young, okay, in the audience, and so he's basically pointing out how, the Young experiment was poo, didn't mean much. Huygens had already argued for this wave theory 200 years earlier. So some of this is all just bullshit, 150 years earlier. And that's what I'm arguing. It is bullshit. It's old. Theirs is the old archaic theory. And it's Huygens. And if you look at what Huygens says, it's just supernatural God theory. It's an infinite number of mini waves inside of something. It has, on its face, silly premises in it. So you're the people with the archaic theory.
Wave propagation, and that's from the 1600s sometime. So this debate went back, and Newton had done many experiments himself, which should have been interpreted as interference, waving.
Again, so we're talking about small aperture experiments. Those are and reflective experiments that Newton did, and he's saying that Newton should have presumptively concluded like they did. And Newton was more cautious. Newton was a better scientist, frankly. Newton talked about what he could demonstrate, not what he couldn't.
Interference. But he didn't. In any case, after these experiments, Young's experiment, others, it was definitely confirmed.
All right, so it's confirmed. So it's nailed and it's confirmed based on this simplistic, and it is simplistic, diagram. Because if you go deeper, it doesn't get better. It gets more convoluted and less explicit.
That light is made of waves. Okay, what kind of waves? Well, that took Maxwell. Maxwell realized that they were waves of electric and magnetic field.
Right, waves Maxwell believed in ether. So again, this is their modern physics, which essentially is the oldest physics you can get. Okay, you're going all the way back to the atomist versus the Platonist and blah blah blah, and they believe in their continuum and their infinite number of fields. They'll just create a bunch of magical spaces that create magical phenomenon, and they don't have to account for any of them. They don't have to describe them. They don't have to in any way have any physics. They just bend something that doesn't exist. Bend a nothing, and that's the foundation of physics. Bend a nothing field. And these people ridicule People looking for a rational explanation as having their head stuck in the archaic past, when you're the people stuck in the archaic past.
You know what an electric and magnetic field is? An electric field.
Yeah, we know what it is. No, nobody knows what it is. Nobody's got a single clue what one of these fields is in any way whatsoever. You've just made up a bad diagram, a bent space bullshit. You just invented a fake fields, two fake fields, and put them perpendicular to each other, and synthesized something that duplicates consequence in some way. But it's not accurate. It's not the truth. It's certainly not proven the truth.
Well, look it up if you don't know. Electric and magnetic fields. And light is a wavy motion of electric and magnetic fields.
Right, so that's a physicist. That's doing hardcore Stanford physics. Light is a wavy thing in the fieldy thing. Sorry, not good enough.
First of all, light is a wave, and here's a wave moving down the axis. What is that wave a wave in? Well, it's a wave of electric field. Here the electric field is pointing down. Here the electric field is pointing up. Here the electric field is pointing down.
Right, and those would be, could argue that that would be a change in the disposition of the quanta. You know, there's somehow more going one way and less going the other way. But there's no. This is just the time. It is and it isn't. It is and it isn't. Okay? That's it. There is one, there isn't one. There is one, there isn't one. Empty space between things will give you the same exact phenomenon.
Let's just draw a line through there.
I mean, it's just a 1 0 1 0 1 0. It can be duplicated as just a frequency. No need to wave it.
Alternating electric field, up, down, up, down.
Okay, so the part I would argue is there's no evidence of an alternating field in the sense of positive and negative charge. Because as demonstrated, there's no way to move a photon with anything like charge or magnetism or any kind of force we know of, except the magical gravity, which, again, we don't have any hard evidence that photons are actually moved by.
And the whole thing moves off with the speed of light. The whole thing
Well, you're supposed to draw the other half of the curve, which is the magnetic element going the perpendicular.
moves off with the speed of light. Electric field, incidentally, there's also a magnetic field attached to the thing. It's a complicated object. It has magnetic
A complicated object. So again, the simplest thing in the universe is now the complicated thing in the universe. Simple force is now complicated for no reason besides just saying, let's just say it's not a wave, then what are we stuck with? Oh, that's right, a frequency of elements, bits, of capable of moving something. Capable of being a ping pong ball and banging into something.
field also. The magnetic field is perpendicular to the electric field. And so it sticks out this way. And that's what a light wave would look like if you could see, if you could sample its electric and magnetic field as it went past you.
Right. So again, and my simpler argument is no. Photons are just simply little bits at a frequency. Period. Nothing, no complexity. None of this is necessary. And when they hit an electron, that's when they create perpendicular release of force, or they move the electron. That's when they create the polarized phenomenon. They'll either move the electron, or the electron will release the energy that came in perpendicular to the direction it came in.
Of course, as it passes you, It will constantly alternate very rapidly if it's a ordinary light wave, much too rapidly for you to be able to see. But if it were an extremely long radio wave, very, very long radio wave, you might be able to see the field oscillating in front of you, and this is, as I said, what it would look like.
Well, yeah, I mean, clearly you'd be able to see it because the length of one of these bends can be meters, or theoretically a mile. So yeah, but you're not going to see anything like that. All there is a distance between them. So if it's a 10-meter wave, it just means the tons are 10 meters apart between the tons. The bits, the on bits, are 10 meters apart on the same path.
It's a wave. Being a wave, it will exhibit interference patterns, and Maxwell had absolutely nailed the wave and the...
Well, let's understand that the wave part of Maxwell's equations mean nothing. The only part of Maxwell's equations that are significant is the fact that Maxwell tied the same rules that apply to gravity, many of them, to electromagnetic phenomena. So the inverse square part and the whole recognizing the perpendicular element to the charge element. The fact that the protons and the electrons, if they don't move, end up releasing electromagnetic radiation perpendicular to the source direction of the force.
Electromagnetic theory of light. So let's talk about waves a little bit before we talk about particles.
Yeah, let's talk about waves, because you don't really talk about particles. There are no particles until you get to electrons and protons and neutrons, and those particles have nothing to do with force, so they're not really particle physics in the strictest sense of the word. So anyway, I haven't watched this part, so it's already 50 minutes, so I think we're done. But again, so this is, I haven't seen Susskind's description of the two-slit experiment before, so this is the first I caught of him doing it. And yes, it was just as sloppy as everybody else's description, and drawn even worse. And this is the nail-in-the-coffin evidence taken with absolutely no seriousness whatsoever. Don't have to be explicit, don't have to be entirely accurate, don't have to really care about the details at all, because it's our nail-in-the-coffin evidence. I'd say right there, you call bullshit. If it's nail-in-the-coffin evidence, you shouldn't be afraid of the details. So anyway, till next time and such.